All right, let's get started. All right, let's do this. So, this isn't my music, is it? Playing? All right, so we got a lot of topics to cover today. Today's kind of a potpourri lecture. It's just a whole bunch of topics that don't have a home as their whole separate lecture. So we'll go kind of rapid fire through a bunch of topics. We're mostly going to talk about how the users are going to send information to our server, which is, of course, HTTP post. But we're going to talk about a lot of what that entails. Let's do it. Here's a post request. I don't have too much to say about this. It's mostly a combination of GET requests and our HTTP responses. So the big thing to know here is that we will have a body to the request, which of course is allowed. These are what post requests do. They will have a body. And this will look like this. It's still following the /r/n stuff. Same thing as all of our requests and responses that we've seen so far. And we will have content length and content type in the request. This isn't just for us sending information to the client. The client, when they're sending information to us, they will use the same two headers, content length, content type. And as much as I don't like ever saying this, I will say it a few times in today's lecture. The content type, when you get a request, the projector looks so dim. When you get a request, you know what the content type is supposed to be, right? Like, we can just assume that the content type is right. In this course, I'm not going to get mad at that. If you never check your content type header for the actual type of the content, there's a case in homework 3 where we'll have to check content type for other information. But if you don't check the MIME type, I'm just not going to get mad at you. I got other things to fight, other things to get you to do. We can drop that one. Because if they're hitting an endpoint for sending you a chat message, for example, you know the content type is going to be application JSON because they're going to send you a JSON string in the body of the request. So you can just assume that, oh, you're hitting my post chat message path. I'm going to assume that you're sending me this in the right format, and we're not going to validate that the user set the right MIME type and stuff. I'm not going to get mad at you for that. And for content length is the number of bytes after this blank line, just like your responses, follows the same exact thing. So if you don't read that many bytes after that blank line, you know something's wrong. There's an issue somewhere. If you have too many or not enough, there's an issue. But I'm also not going to get mad at you until homework 3 if you're not checking your content length. So for homeworks 1 and homework 2, you don't want to think about content length and content type on your requests, on your post requests. Not going to get mad at you. It's fine. Homework 3, we're going to have to check both of them, actually. So for now, just know that these are present on post requests and that they will be a big conversation later in the semester. The big thing that we'll see, kind of spoilers or foreshadowing or whatever, is that sometimes the content length is much larger than the number of bytes you can read at one time from the TCP socket. So you have to enter a buffering state and grab all of the bytes before you process the request. And specifically, that's going to be for image uploads. If somebody uploads a 3 megabyte image, you're not going to read that all in one go. So you got to read the content length to know how long to buffer. So that's kind of a foreshadow of what's coming up. And other than that, post requests are just like your responses. When you're sending a response with some content length, content type, that bytes of the content is after that blank line, and that's that. That's all I really have to say about post requests. Not too complicated, given what we already know about HTTP. Okay, on to query strings. And query strings is, I guess, the third time I'll say this in today's lecture, but I don't think I say it any other. I'll say it a few more times. Query strings, I'm actually not going to make you do query strings in this course, right? I'm not going to add it to any other homeworks. Yeah, I'm not going to have you do query strings, but the format of the query string you will have to parse on homework 2. Right from Objective 1 of Homework 2, you'll be parsing this format, even though it's not going to be in the form of a query string. So we do still have to know about this structure. So let's talk about query strings, which I mentioned in a few different lectures, but let's get a little more into the details of it. A query string is going to be part of the URL. And remember, this is the same exact slide I had before. It's going to be part of the URL, and it's going to be anything after a question mark and before a hashtag. Both of those are optional, so if you don't have a question mark or hashtag, you don't have any query string or fragment. But the query string is going to be preceded by a question mark that says the query string is about to start. And then we have key value pairs that are separated by ampersands, and the key and value are separated by equal signs. And this is what that looks like. Here's a query string with two key value pairs. We talked about this earlier in the semester. The Q is web development, IA equals images, two key value pairs. These go right in the headers. This is actually in the request line of your request. So if you have a query string, that query string is added right to the path. In the HTTP protocol, we call it path. It's method path HTTP version. We just call it path, but it's actually the path and the query string and the fragment if they exist. It's everything that's after the host and port in the URL. That's what's going to go in the path of the request line. All this to say that since that's part of the headers, it's before the blank line, that means it's ASCII only. So ASCII only characters in our query strings, ASCII only characters in our URLs, and that includes white space since our parsers are saying split on spaces, and that's how we're getting those three pieces of information. No spaces are allowed in the URL, including the query string. Can't have spaces, not allowed. Or else all of our parsers would break, the internet would melt down, nothing would work if people started putting spaces in their URLs. So if we want some characters that aren't allowed, so any non-ASCII UTF-8 character, or if we want spaces or any other character, we're going to URL encode those values. How's it going? Good? All right, good. Good to hear it. So we're going to URL encode these values. If we want to have characters that aren't allowed, we're going to URL encode them, and that's going to be percent encoding or percent escaping. I'm going to say percent encoded. I mean percent escaping and URL encoded. I'm going to mix up those words a lot. But this is going to be URL encoded if we want them. So if I want this non-ASCII UTF-8 character, what I'm going to do is use a percent sign followed by the two hex characters defining a byte. This is a 3-byte character, so I'm going to percent encode those 3 bytes by using their hex representation for those 3 bytes. And in this way, we can represent any binary data we want. Any bytes that we want, we can put in a URL, in a path, in a query string, by percent encoding these things or percent escaping them. And for a single space, percent 20, 20 is the hex value for an ASCII space. So if we do percent 20, if you ever see this in your URLs or your query strings or whatever, you've probably seen these if you ever look at a URL. You'll see these from time to time, the percent 20. This means there's a space character that's URL encoded, percent escape, however you want to say it. That's a space character. Often we'll see pluses instead of spaces. Even in the example that I showed, the web plus development, I went to DuckDuckGo and typed web space development and replaced my space with a plus sign. This is common. This happens a lot. If you see pluses where you're expecting percent 20, that's perfectly fine. Everything's fine. It's normal operation. Plus sign, according to the spec, is a separation of values that have the same key. So if I have a key mapping to multiple values, you would separate them by a plus sign. the intent is for this to be like one value stores an array of values. You would plus separate them to say these are all the values. But search engines, at least, and many other things tend to use this for spaces. And I guess my way of looking at it is that they have an array of words, and each word is treated as a separate token for that search or whatever they're doing. So if you see pluses instead of %20, everything's normal. Don't panic. And here are reserved characters. Certain characters have special meaning in URLs. We talked about some of these. : / means I'm done specifying the protocol, or I'm done specifying the host and port, and I'm ready to go on to the path. For slash specifically, but : / ampersand, question mark, hashtag. We talked about a plus sign. We talked about a bunch of these, the equal sign too. But these are the reserved characters. They all have special meaning in URLs, which means if we want these values anywhere in our URLs, including query strings or anything that's URL encoded, these need to be %escaped. These need to be their % representations, and then we can just happily use these characters. We just % encode them. There are a few notable characters that are not reserved: dash, dot, underscore, and tilde. You see these all the time in URLs. If you look at URL, I don't know how much y'all look at URLs. I look at URLs a whole bunch because, I don't know, I'm like that. But if you look at URLs, you'll see these characters a lot. It's because it's all we have to work with. Everything else has to be % encoded, and that gets gross if we have a bunch of % encoded URLs. So these characters will often show up in our URLs when we want to use some special characters. And this structure is going to, again, be important, starting with Objective 1 of Homework 2, not released yet. I want to get that out sometime soon, maybe over the weekend. At the very latest, before the Homework 2 content starts. I don't think I've said that in this lecture yet, so I might as well right now. My deadline for myself is to get every homework released before the content for that homework starts. So the other lecture is at 2 p.m., so 2 p.m., on not the upcoming Monday, but the following Monday. That's when the Homework 2 content starts. So the Homework 2 will be out by then. That's what I'll hold myself to. But I want to get that out much, much earlier. I got it pretty much designed. I just got to write it up and write the grader for LO1. So I want to get that out much, much sooner. But Homework 2, you will have to parse this format and look for these reserved characters, look for the % encodings of these, and replace them with their actual characters. So we do have to be aware of this. Okay, any questions on this so far? I'm not on the wrong Wi-Fi again, am I? On UB Connect for some lectures and wondering why nobody's using chat. I guess today just nobody wants to use it. That's fine. It's Friday. We all want to go home. I know. I want to, too. All right. Well, let's move on. We got some more stuff to talk about before we can go home. HTML forms. So I won't talk too much about HTML. You know, I mentioned that I'm just going to show you what HTML is. But when we need specific elements, I'll bring them up. So I will talk about HTML forms specifically because it has some functionality that we want to take advantage of. And what we want is our pages to be our web pages, what used to be our web pages, to become web applications. That's what we actually want to do in this course, and we haven't built any web applications yet. We haven't talked about them at all. That ends right now. We're going to start building forms where the users can start interacting with our server. The users can't interact with the server if you're just, sending information to the user. Sorry I asked. Hi. So once the users can interact with our server, and usually, I lost my word. Ideally, users interacting with each other through our server. That's what we want. That's the first thing that we're going to build right from LO3 of Homework 1. We want users to be able to chat with each other, pretty much the most basic thing that we can do on the internet, just sharing text with each other. So they can send text to each other and see each other's text. At that point, we will have a web app. It'll be a chat app, but hey, we got to start somewhere. So we're going to have a chat app. That's what we want, and build an actual web application. Yay. Instead of a web page or a website, a web application. So let's do that with HTML forms. This is our first thing that's going to let our users interact with our server and interact with each other eventually through our server. Here's an HTML form, and let's talk about the code. There are a few elements that we want to talk about. I won't go into absolutely everything. Again, W3 Schools is really cool for front-end stuff to learn more, but I'm going to show you what we need for this course, and then you're welcome to look at more if you're interested. So a form element, we have the start tag, the end tag, and we have these two attributes are going to be, for starters, the important ones that we'll use. These two attributes, for action and method. Action is going to be the path, which I wish they just called path. I think there's a good reason why it's action, because it doesn't have to be a path of the server that you're sending to. But action is going to be our path, and then method, which HTTP method to use. When this form is submitted, this is going to send an HTTP GET request to /form path to your server. It's going to send that request to your server. Your server is going to do whatever it does, do its cool stuff, and then it's going to respond with an HTTP response. Just as usual, your server doesn't care that this came from a form or not. You're going to respond with a response, and then the page is going to be reloaded to whatever you respond with. An HTML form will force a page reload. Is going to be an important thing to know. It's just like when a user clicks submit here, it's just like they clicked on a link, and that link is going to send off a GET request to this path. So something that we'll have to keep in mind for about 20 minutes, and then we're going to undo that and use a form that doesn't force a page reload. And then we have a few other elements here, a few other element types. Input. Input is wherever we want something that's going to interact with the user, or rather the user is going to interact with. And we have type. Type is going to be the type of input. I'm using text here. That's going to give me a good old-fashioned text box. So I just put input type text. That gives me a text box, and the user can type in this box like any other text box you've seen, except with no styling attached to it yet. And this is where I'm going to say W3 Schools is awesome. If you want to look at all the different types of inputs, W3 Schools or just the internet in general, and look at how to do radio buttons, checkboxes, drop downs, all the cool form stuff that we are used to on the internet. For the homework assignments, we'll just need text boxes. I don't think I use any other ones. Text boxes and in file will be a big deal. I think we just use those two and then submit. But if you want to look at the other ones, especially for your project, you want to have some radio buttons and stuff like that, they're out there. It's actually pretty fun to do, but I just don't have time in lecture to talk about each one of them. So this is going to give us a text box, and then name is very important. Name, I have name of commenter, so this text box has a name of commenter. That's very important to have some meaningful name here. And let me just say why. That's important because when the user fills out this form, we're going to get a request on the server, and the information that the user typed into this box is going to be under the name commenter, whatever name we gave that text box. So when it's a query string, spoilers, it's going to be a query string. When the user submits this form, one of the query string key value pairs is going to be commenter in whatever the user typed in here, and then comment in whatever the user typed in here. So the name itself isn't too important. You should use good naming conventions and things like that. But you need to be consistent, because whatever you put as the name on the front end is the same thing that you need to code your back end to be expecting. You need to be expecting that same exact name. So you have to be consistent front end and back end with these names. And then please use labels. I say should, but I say should in the sense that your web app won't explode if you don't use your labels. It will still run, but please put your labels on here. For a few reasons. One is accessibility. When this renders, if I don't use label, if I have the same code but I just delete the label here, it'll render the same way. And I can tell that enter your name is this text box. This is where I should enter my name. I know that. But what happens when somebody's accessing your app through a screen reader because they're blind and they can't see your screen? They're visually impaired and can't see the screen. they're using a screen reader to read it to them, and it says, the screen reader says, this page says, enter your name, comment. And there's 2 text boxes. How are they going to know where to type and what to do? If you have a label, the screen readers know how to read this and say that this text is associated with this input, and they're able to get that information and get their stuff in the right spot. There's also a more practical reason for all of us, not just visually impaired and screen readers, is when I click, if I have my label set up properly like this, and I click the text here, it's going to focus this text box. For this, maybe not too big of a deal here, but one of my pet peeves on the internet is when it's the radio buttons, when it's the small, if you don't know what I'm talking about, the radio buttons, like the multiple choice questions for lecture questions, those are radio buttons is the term for them. The little circle things, where only one can be selected out of a group. That's, if you don't have your label associated with them, you got to click on that exact circle, that little circle. I'm getting older. It's hard for me to click that thing. But you got to click on that circle exactly. If you have your label set up, you can click anywhere on the text associated with that. For the lecture question, if you want to say C, I don't remember what the answer is today, but if you want to say C for the lecture question and you click the text C, it's going to select the appropriate radio button for that. The one thing that bugs me that I have to use all the time is signing TA timesheets. There's a checkbox and a label, which should be a label next to it, but it's not associated. It's not an actual label. So when I click the text, it doesn't work. I have to actually click the box itself. Yes, it's a pet peeve, I know, but when I have to do this for, they're not, I guess some of them are under Paul as supervisor, but there's 47 TAs in 116 and 15 in 312. I got a lot of TAs, there's a lot of timesheets, and to get that little frickin' box every single time, it's tedious. It gets annoying. So for that pet peeve or for the accessibility, please just add your labels properly like this. And then if there's an input inside a label element, it knows that any text is associated with that input. Okay. Let's move on. I don't have many things to say about front end, but that's just such a small thing that you can do to really improve the usability of your apps. And it's a pet peeve, so I make sure I talk about it. And then I have an input with type submit and value submit with a capital S. The type submit means give me a button, and when the user clicks that button, submit the form. The value submit, and I probably should have used something different for the value, but the value is going to be the text that's displayed on the button. So notice the capital S, it's capital S on the button, but it's really whatever I put here. If I put click me, this is going to say click me on the button. So the value is the text to display on the button itself. And then we put it all together. The user fills out the form and clicks submit. What we're going to get on the server is a GET request with a path matching the action and a query string with whatever the user filled out. And notice our percent encoding, my exclamation point got percent encoded to %21. My space got replaced with a plus, and I'm fine. I'm not going to panic about that. My space is a plus, and I'm okay with that too instead of a %20. This is what we're going to get is a query string with the values that they filled out. And commenter, comment, matching the names, whatever I type here. If I type something different here, I'm going to get something different here. Make an extension for that. I forgot what I just said. Oh, I should. Yeah. Yeah, thanks for that, Clay. Yeah, I should write an extension for that. I actually got to talk about extensions in 116 today. That was fun. I talked about extension in 116 before I talked about it in 312, but it's kind of weird. I wrote an extension for the tracing tool that we use for memory diagrams, and they're like, why does your tracing tool look different than mine? So I had to talk about the extension that I wrote. Why don't I write an extension for TA timesheets? I'm doing that. All right, so this sends a GET request with whatever the user types in as a query string, and you have a user who pastes the B-movie script into your chat box, and everything breaks. So there's a problem with this. There's a limitation. Like in theory, that works fine. Everything just gets percent encoded. The spaces might turn into pluses, special characters percent encoded. Everything's fine. But the problem is there's a limit to how big the request headers can be, including the request line. So everything before that blank line, everything before the actual content, there's a limit to that size. Different browsers and different frameworks. And different frameworks and libraries, they all have different sizes as their limit, but they're all going to have some limit, with some notable exceptions, like the ones you write for your homework. You're probably not going to enforce any limit on yours, but anything we use out there in the real world and the browsers that you're communicating with will have limits to the size of your HTTP headers. And this is usually just a handful of K, sometimes like tens of K, but we want to keep the size down so we don't hit these limits. So we can't use this. The B-movie script would hit this limit, done. And what happens when we want to do file uploads? Homework 3, we're going to do image uploads. How are you going to upload an image when you say on your website to your end users, hey, your images can't be more than 4K? Like, sorry about that. But I only know how to make GET requests. So, all right, so let's learn post requests. We're going to take our form, and we're just going to change the method to post. What else do you want me to say? We change the method to post. Now it's a post request. Oh, yeah, I did miss a question. I'm staring at it. I'm missing it. It's been a long day. Can we name the variable whatever we want? Would it affect anything instead of commenter? We call it another thing. In general, yeah, you can name it whatever you want. For this course, the way you're going to see a form that looks like this for login. I mean, it's right there in the front end that you have now. For registration and login, make sure you keep those names the same because it would mess with my autograder when we get to LO1. It's going to mess with my autograder. So please leave those ones alone or else you're going to have some errors on LO1. For the homework 1, the comment, it's sending a JSON string in a specific format with comment and then the actual comment. Make sure you keep that the same as well because the spec on your back end is to handle JSON strings in that exact format. So don't change them in this course just because it's the spec that we're agreeing with based on the homework documents. But in general, yeah, you can name these whatever you want. These have no special meaning except the meaning that we assign to them as developers. And when we change get to post, we get a request that looks like this. It's going to be the same exact thing. Everything's the same except that query string moved down to the body of the request. It's still URL encoded, and this is why we're still going to have to handle URL encoding even though it's not part of a query string, because this is how the registration and login forms are going to work. But we're not using them in the query string, and since this is in the body, we don't have to worry about those limits to the sizes of the headers. Since all of that will be in the request line, it's going to be counting against us for that size limit. So now we're all good. Now we have content length, content types, URL encoding, and then we parse this as a post request instead of a query string. Problem solved. Okay. On to the next topic. We got a lot of topics. It's rapid fire today. So it's not, yeah, it's just to keep things organized. It's just like a variable name in your code. Like you should pick good variable names. But if you don't, your code's not going to explode, but your coworkers might get really mad at you. So you can choose whatever you want. But try to be sensible about it. Unless you're the only dev on the project, then go nuts. Do whatever you want. Actually, on the front end, your users could view the source and see those. So if you say, God, I hate all my users, use common sense. But anyway, let's move on. AJAX, if there are no questions. If there are questions, I'll watch chat and watch for hands. But I want to try to get to the end of the slides. I got to all but one slide in the other lecture. I think we can do better. So we want our users to interact with each other. This is ultimately what we're building. But with the form, when you submit the form, it's going to reload the page. That's true for get and post. All the forms that we saw are going to reload the page with whatever you respond with. So a user submits the form that sends the get or post request, whatever request type they're sending, it's going to send that request. Your server does its magic, and it responds with an HTTP response. Whatever you respond with is what's rendered to the page for the end user, and the page reloads with that content. So ideally, you're responding with HTML with the new page that they're visiting. After that form submission, maybe it's some HTML that says, thanks for your form submission or whatever. Or it's going to be a redirect. In our case, it'll be a redirect. Send a redirect and send them back to the page that they were at. Send them back to your home page after the form is submitted. That's not something we're worrying about with homework 1. I know I didn't talk about redirects yet. That's a homework 2 thing. For homework 1, we're going to do something different, which we'll see on the next thing. But the form, HTML form, the way we saw, will reload the page is the bottom line for that, is the important point of that. So enter AJAX, asynchronous JavaScript and XML. We don't use it with XML anymore, but the acronym stuck. We're stuck with XML being attached to AJAX forever, even though XML is not something we really use anymore. We're going to use JSON for everything. So this is a way that we can make an HTTP request after the page loads, which is something we can't do. In everything we've said so far, we can't do this. We can't have the user send an HTTP request after page load. So they get our HTML, they scan that for CSS, Java, any other requests they make. They make all those requests, they get all those requests, render the page, bless you. The page is, I thought you had another one coming. The whole page is loaded, and then after that page loads, we can't send another request without reloading the page. We can have a URL, a link on our page. They click that link and go somewhere else. We can have a form. They submit that form that takes them somewhere else. But it has to be a page reload if they send another request. So how do we send a request after the page loads without reloading the page? AJAX is our answer. This is why we use AJAX. And without AJAX, our pages are pretty boring. The page has to reload whenever you do anything ever. So that interacts with the server. So AJAX looks like this. We're going to create an XML HTTP request. The XML just kind of tagging along for the ride for the rest of this. I wish they would just rename this HTTP request, or AJAX requests would be nice. But XML HTTP request, we're stuck with XML just hanging out on our AJAX requests for the rest of eternity. So we're going to create a new object of this type, and this is built into every browser. They're going to support this class, this XML HTTP request. We're going to call its open method. The open method takes the request type, the HTTP method, and the path. So this is going to be a get request to /path. And then we call request.send to send the request. And that's it. These 3 lines is all we need to send an HTTP request to the server after the page loads. And this is JavaScript. We can do it whenever we execute any JavaScript on reacting to any event, we can fire this thing off. The rest of this on-ready state change, this is what we're going to do when we get the response from the server. We're going to say, when I get a response from the server, do this stuff. We're going to do this through the on-ready state change field. I've been deciding what to call these things in 3.12. I'm going to stick with fields, I think. It's in 1.16, I used to call them state variables, so you might have took it when I called them state variables. These days in 1.16, I call them instance variables. I prefer fields, but those make more sense in 1.16 because they're more descriptive. Now in 3.12, I only want to say one syllable, so I'm going to use field. But it's a field, but it's a variable associated with this object, whatever you want to call them, I don't care. I'm going to call them fields in lecture. So we're going to set the onReady state change field to a function. This is a field that stores a function, and this function is going to be called whenever the ready state changes. So we send the request, and whenever the ready state changes, it's going to call our function that we set to this field. The ready state is going to change to different integer values as the request is sent and being processed and responds. The one we're interested in is 4. When the ready state is 4, when it changes to 4, that means we got the response. We got the whole response. It's done buffering if there was buffering involved. Everything's good. We read the headers. We processed the content. We got rid of the headers, and here's the content, just the body of the response. So if we're done getting the response, and I'm going to check the status. This is the status code, so 200 OK. If I got the entire response and the response was a 200, everything's fine, and I didn't get 404 or anything, then I'm going to execute this code. So this function will be called multiple times without these conditions, and if the state's changing to buffering, I don't want to do anything yet until I got the whole response, ready state 4. And then, so once I get the whole response from the server, in this case, I'm just going to print it to the console. Like, I'm not doing anything with it here, but this is where you would do your stuff, and this is where the homework code, the front end, the front end's there for you. You don't have to modify it much or at all in homework 1. You'll have to start modifying it as we go through the semester. I don't think you have to modify it at all for homework 1, right? But anyway, this is where the front-end code, when it gets your chat history, it's going to render that to the screen. So when it calls chat history, get me my chat history, it's going to, in one of these ready state change functions, parse that chat history and render it all to the screen with username and message and a delete button. So you can look through the front end for an example of how that works. If we want to make this a post request, we just make it a post request. We replace get with post. What more do you want from me? There's one more thing, though, we actually have to do, is when we call send, this is now going to take an argument, and it's going to take whatever we want the body of the request to be. If we want it to be some actual content, we're going to stuff that right in the send method call. This is how we're going to send JSON with AJAX requests. Okay, and we can use this with HTML forms. We're getting close to what we're actually going to use. We passed what we're going to use in homework 2 with registration and login. I mentioned that when we hit that checkpoint. But we're going through a progression of our forms to finally how the chat form on the homework 1, how homework 1's chat form actually works. We're almost there. This is the penultimate way we're going to do it. So I have this form just the way we had it set up before, except I'm going to use onSubmit instead of method and action. I'm going to use onSubmit and give it some JavaScript. We're going to give it a JavaScript function to call that's going to be called when the user submits. Reacting to the submit action, we're going to call this JavaScript, and then return false, which is going to shut off the rest of the submit action. So it's going to override the default action of the form, which is reload the page with the response that we get. It'll send the request and reload the page with the response. Return false is going to exit that method and not let the form do what it's supposed to do, what its default behavior is. So we're going to call our code and then shut everything down after that. Our code is going to grab the form, create a form data, a form data object, and then just stuff that form data right in the request. And what this does is sends that URL, I don't think I have an example of that, sends the URL encoded form data, same thing that we had before, but as an AJAX request. So we have an AJAX request, but the request looks the same as when we submitted the form as before. It's still a URL encoded string, looks like a query string in the body of a post request. But it's AJAX, so it doesn't reload the page. And finally, how our chat actually works on the homework. The last one we're going to see is we're going to say, you know what? I don't want to use HTML forms at all, because we're not really using them as HTML forms anymore. If we're overriding the default behavior and we're grabbing the values directly, and the values end up being URL encoded, like, it's just kind of a mess. So we want to use JSON. JSON, we love JSON in the world of the internet. So we have this chat input without an HTML form. Now, with an HTML form, we had a submit button. It was an input of type submit, and that gave us our submit button, which was a special button that submits the form. We don't have that accessible to us anymore, so we're going to create an old-fashioned button. We're going to create a button element, which is just a button. It's just flat out a button. Whatever's in between the tags, the text of the element, that's going to be displayed on the button. And the button itself doesn't do anything. If you just create a button, the button doesn't do anything. We have to give it something to do using an onClick. So when this button is clicked, we're going to call some JavaScript. This JavaScript is going to go to the chat input, go to this input, grab its value, stuff that in a JSON object, and stringify that JSON object. Now I'm sending JSON over the internet in my post request instead of messing around with URL encoding and percent encodings and all that stuff. Now it's just good old-fashioned JSON. That means when you get this JSON string, if somebody put a whole bunch of emojis in their chat message, or they're not speaking English, they have characters and special characters and everything, you don't have to worry about percent encoding at all. It's just UTF-8 encoded. You get those bytes, .decode, and you have the characters. Done. No extra work. Everything's handled through the UTF encoding itself. So that's one reason why we like JSON. We like it for lots of reasons, though. And that's how the chat form is actually going to work. And if you look at the handout code, that is how it works. Yep. So this doesn't reload the page. Since that's part of an HTML form. If you have an HTML form with an input of type submit and you click that submit button, the behavior of that form is to reload the page. Since we're not using a form anymore, we're using an old-fashioned button, and that button sends an AJAX request. This will not reload the page. So now when the user types into chat and hits submit, the page will not reload. It'll be an app that they're interacting with, not pretending we have interactions by reloading the page every time they do something. So we got there. This is it. New in chat. Any other questions? Making better pace than the other lecture. We are going to get to the end. That was a lot of work, but we got here. Oh, and with AJAX requests, I almost forgot to say this. With AJAX requests, how to handle AJAX requests on your server, because now you have to handle this different type of request. What you do on your server to handle AJAX requests is nothing. The same exact thing you do to handle any other request. Your server doesn't care if that request came from a form, came from clicking a link. It doesn't care if the user isn't even using a browser and just manually created their own TCP socket and sent over some data, or an AJAX request. Doesn't care. Your server doesn't care. When this is sent, your server gets a post request at this path with this content. If it's a form submission, you get a post request at that path with that content. Your server doesn't care. If you get an AJAX request, you handle it like any other request. No special difference. You don't care if when you send that response, the user's going to reload the page or not. I mean, you do, but it's the way you design your page and design your app entirely. You don't do anything special about that. Like if it is a form submission, a regular old form submission, you should make sure that your response contains either a redirect or HTML, so they're actually looking at web content. Don't just send thanks for your form submission, because they'll just see in plain black letters in the corner of their browser on a white screen, thanks for your form submission, with no styling, no frills, nothing at all. So you do want to make sure they're seeing HTML in that case. So in that case, you care from a design perspective, but from a functionality perspective, you don't care. AJAX requests just look like regular HTTP requests. Who cares if they were sent asynchronously? Not your server. What is the meaning of life? Well, the study for 312. Manually, JSON would be the JSON.stringify. Yeah, well, send takes a string. Send will convert some types into strings for you, but I always lose track of what types it does or doesn't. You might be able to just give it data here. It might stringify it for you. I don't remember. But if you stringify it, you don't have to remember. It's just a string at that point. Like the form data, we didn't have to stringify. We didn't have to do anything. We just gave it the form data straight up. Life. Oh, I don't know. I always like to say the pursuit of happiness. If you're happy, you're doing it right. So that's my more serious answer. All right, so polling. The problem with everything that we're doing here is that we do still need a request. I introduced that wrong. But we need a request. We need an HTTP request in order to send an HTTP response. We have no mechanism in what we've learned so far in this semester for the server to just send information to the user. Whenever the user wants, in our homework 1 example, the latest chat history, they're chatting, they're using the app, they send a message, they click enter, we respond with something, they could see the new chat. If we're using an HTML form, we're going to do polling in AJAX. But when they see the new stuff after they submit the form, and somebody else sends a message to the chat, sends it to the server, it's saved in the database and everything, and the server is waiting to give you that information, but it can't give you that information until you send a request. So the user either has to send their own chat message, get a response with the latest stuff, or manually refresh their page, click the refresh on their browser to see the latest chat. We don't like either of those solutions. We want the user to just sit there. If they just want to sit there and watch the chat, they should be able to do that. So we need to be able to send a request without the user doing anything. That's where polling comes in. So polling is going to send these AJAX requests, specifically our chat history request or chat messages. I think I made it get chat messages. But they're going to get the chat history through an AJAX request that's triggered by polling. So